Welcome everyone. In today's session on graph theory, we're gonna see introduction to trees. So if you're new to my channel, please don't forget to hit the subscribe button and also press the bell icon next to it. So let's get started. So tree is a discrete structure that represents hierarchical relationships between individual elements or nodes. So what do you mean by hierarchical relationships? Hierarchical relationships can be your relationship like your grandfather, father, and a son. So those are all an example of an hierarchical relationships. So a tree in which a parent has no more than a children is called a binary tree. So as you can see in the diagram that is drawn here on the right side, a tree in which a parent has no more than two children is called a binary tree. So this is nothing but your binary trees. Okay. So what is a tree? A connected acyclic in the sense which is not cycle graph is called a tree. So in other words, a connected graph with no cycle is a tree. So the edge of a trees are known as branches. Suppose that this is example. In this example, this is a tree and the edge of the tree. We have two edges here which is called branches. So the elements of the trees are called as nodes. Okay. The elements, which means each element, this is one element, this is one element. So these each elements are called as nodes. Whereas in graph we call them as vertices. Okay. The nodes without the child nodes are called leaf nodes. So if a node does not have any child node, then this end node is also called as a leaf node. So a tree with n vertices has n minus 1 edges. In this example, we have n vertices. Like for example, in this we have 1, 2, 3, 4. So we have 4 vertices. And n minus 1 is nothing but 3. We have 3 edges. Okay. So if it has one more edge extra than n minus 1, then that extra edge should obviously has to pair up with the two vertices, which leads to form a cycle. Then it becomes a cycle graph, which is violation for a tree graph. Let me take it in a form of an example and show you. So the graph shown here is a tree because it has no circles. Correct? This graph is an example graph. It's shown here has no circles and it is connected. It has connection. It has 4 vertices and 3 edges. That is n vertices and n minus 1 edges as mentioned in the definition. So we have a note here. Every tree has at least 2 vertices of degree 1. So what do you mean by every tree has at least 2 vertices of degree 1? So here we have a graph, for example, this graph G. Here we have the degree of this vertex, like A is 1 as it has only one edge, degree of B is 2, and the degree of C is 2, the degree of D is 1. So every tree has at least 2 vertices with 2 vertices, okay, it has at least 2 vertices of degree 1. So in the above example, vertices A and D has 1 degree, correct? A and D has 1 degree and another 2 vertices B and C has 2 degree. This is possible because for not forming a cycle, there should be at least 2 single edges anywhere in a graph. It has nothing but 2 edges with a degree of 1. So example, if you take this graph or this tree, usually trees is graph is represented by G and trees are represented by T if it is a tree. So if you see, this has 1 degree, it has 1 degree and it has 1 degree, while the center has 3 degree. So it means has at least 2 vertices. Okay. Now let's see what is a forest. So a disconnected acyclic graph is called a forest. In other words, a disjoint collection of trees is called a forest. Here we have a set of trees. They are not connected by any vertex or any extra vertices or any edges, which means they are separate. So the following graphs looks like two subgraphs, but it's a single disconnected graph. There are no cyclic graphs, hence it's clearly a forest, which means a group of any group or collection is said to be a forest. Okay. Thank you.